Good morning, guys. I hope you're well. Today we are looking at finding the unknown angle in a right angled triangle using trigonometry. So the last couple of lessons, what we've been working on finding a side of a right angled triangle. Sometimes the unknown was the numerator or the denominator, depending on the challenge of the question. So today we are going to look at what happens when you are given those sides, but you want to reverse that process to find the actual angle or theta. Now, before we do that, of course, I want to look at this question. This is a review question. So I thought it might be a good idea just to get our heads back into it if we've had a bit of time out. So first of all, think about your trigonometry. I want you to reflect on our SOHCAHTOA, okay? SOHCAHTOA, thinking about how would we usually find the side of a right angled triangle using trig. So my first step has always been to label the sides that you've got in regards to theta. So in this instance, the x would be our opposite side, whilst our 6, of course, would be next to it, be our adjacent side. So using this, we can identify that TOA is what we'll be looking at. So remember, my first thing I always want to see is the minimum of the rule with the value substituted into it. So for example, that means tan 50 degrees equals my x, my opposite, over my adjacent of 6. So I must see that line of working. Now, if you want to then put the answer, that's fine. Okay, but for me, I'm going to write x equals 6 times tan 50 degrees. I'm then going to go to my trustworthy calculator there. So 6 times tan 50, making sure I have my little D on my screen to make sure I'm in the right mode. And I get x equals 7.1505 ... Okay, I now go to my rounding. It says to 1 decimal place. So the 1 is being pushed up, of course, by that 5. So we get an answer of 7.2 centimeters. Hopefully that's something that you remember from our previous lessons. So now let's look at what happens when we don't have the angle. We want to reverse that process. Now, of course, if you remember this from last year in Year 9, you would like to go ahead and have a crack at these questions. By all means, just be cautious of our rounding. I've given us a couple of different ways to round the question, but certainly if you remember how to do these, feel free to press pause, and then you can fast forward to have a look at your answers if they're correct. Okay, so for this one, okay, I want you to think about these questions exactly the same as that previous question we're finding a side. Nothing really changes apart from one little thing at the end. So my first step, of course, is to label the sides in regards to the angle given. This time actually is theta. So for example, 5 would be the opposite side, very similar to that last question. And the 8 again would be the adjacent. Oops. Okay, so 8 would be the adjacent side. Now, I don't have SOHCAHTOA on my screen, so I'm going to write that down, SOHCAHTOA. Remember, it's really important, I think, if you keep on writing it down, you're going to remember the rule. Okay, so which rule am I using? Well, like that last question, we're using TOA. So still, my same steps will apply. I'm going to write down tan, this time it is theta. My opposite side is 5, my adjacent side is 8. I still write that down. I must see that line of working because it's my rule with the value subbed in. Now, this is where the kind of question takes a little bit of a turn, because if I times it by the 8 like I've been doing previously, I've got this unknown theta. I can't press tan theta on my calculator. It doesn't work. I don't know what the angle is. It could be anything. It could be a decimal. It could be a rounding question. So I can't find theta in this instance. Now, technically speaking, often I say to people, what's between the tan and the theta sign? Everyone says, oh, it's a times. And technically speaking, it kind of is, right? The problem is, you might say, well, what's the opposite of times tan? You might say, hey, it's divide by 10, right? And you do that, and you divide by 10, and then you chuck in your calculator, and the problem is your calculator says math error. And that's because you can't separate tan and an angle. Okay, tan must be with an angle. Okay, it's a function, it's a ratio of two sides that are the angle. We can't do that. So if you might think back, though, to maybe Year 9 or Year 10 indices, you might remember that there's a way to write a fraction with a negative indice. For example, we might have 1 on x. We could write that as x to the power of -1. And you might see on your calculator that there is a button very close to your tan that looks like that. For example, if I said theta equals, instead of dividing it by tan, I'm going to say tan to the negative 1, because technically that's the same thing. And then I say 5 over 8. 5 over 8. You can see we now have a ratio that goes with tan, even though it's a negative indice. That's fine. But it works, right? And if you look at your tan key, and I can see it here on the screen, you look up in yellow, you can see it says tan to the negative 1, which means for us, we can actually press our shift tan, and you see the tan negative 1 comes up. I can type in my 5 over 8. I'm going to close those brackets, of course. I'm going to press equals, and it comes up with 32.00538 ... Now, it says to the nearest degree. That means the nearest whole number, which of course would be 32 degrees. And that's your first question now where you found the angle. So what was the one step that was different? Well, it's this tan negative 1, okay, or otherwise known as our shift tan. Now, whenever you find an angle with trigonometry, no matter what type of trig you're using, if you're finding an angle, you need to press shift at some point. At some point. It's so critical. If you don't, the answer is going to be incorrect. So when you start to see a question where you're finding an angle, think, I've got to press shift at some point, whether it be shift cos, shift sine, shift tan. I like this line of working out because it helps me to remember, hey, I don't have tan, I have shift tan or tan negative 1. So I like to see these three pieces of working as a bare minimum. So the rule with the value subbed in, the theta equals the shift tan or tan negative 1, sine negative 1, cos negative 1, and then my theta. Now, of course, there might be some slightly different rounding. We'll look at that as we go through. Okay, I know it's a lot to take in, but hopefully you're kind of understanding that. Now, let's look at this third question, right? The same rules apply. As I said, for all my questions, whether it's side or angle, the same steps will apply. That means I'm labeling my triangle or my sides in regards to the angle given. So in this instance, of course, in regards to theta, the 7 is the opposite side, but the tan in this case would be called the hypotenuse side. So again, I go to my SOHCAHTOA, okay, and I see which side uses, which rule, ratio uses O and H. Well, it's my SOH, my sine rule, okay? So I now write down sine theta equals my 7 over my 10. Notice that whether I'm finding a side or an angle, that has not changed ever, okay? So it's my next step that changes because theta is the one I need to get on its own. We can't divide by sine. So what we do, we're going to use that sine to the power of negative 1. That's the same thing as dividing by sine. And I'm going to put 7 over 10, so we have a ratio attached to it. I want to see both of those lines. The next part, of course, if you want to write your answer down, that's fine. So my last step now is to go ahead to my calculator. I'm going to press shift sine, and you can see in my calc, it comes up with sine neg 1. I'm going to type in 7 over 10. Now you might want to just type in 0.7 as a decimal. That's what you want, that's fine. I'm going to press equals, and it comes up with 44.427 ... Now, the rounding in this instance is to one decimal place. Well, we're used to that. So we have the 4, the 2, so it stays the same. So 44.4, and it's degrees, and that is now my answer to that question. So again, they're the three lines that I feel that I must see as my working out. So realistically, the only difference we're doing with these questions, right, is we're pressing shift at some point. Remember, whenever you find an angle, you must press shift at some point. All right, I've got two more questions. I'm a bit mean on question 4 because I'm making the rounding harder. But again, I would like you to have a crack at these questions to the point where you have to round and see if you can come up with the correct answer. Okay, so how did you go? Now, in regards to theta, we have so 8 is the adjacent side, it's next to, and the 12 is the hypotenuse. So again, I don't have my rule there, so SOHCAHTOA, and hopefully we'll recognize that we're using A and H, therefore it's the car rule, okay, cos. So I'm going to now write my rule out. We're going to have cos theta equals 8 over 12. All right, that's my first line that I must see. I now recognize, hey, I'm finding an angle. We must do cos the -1 or shift cos. Cos -1, I'm going to write my 8 over my 12 in brackets. Now I can go into my answer. So I'm going to get my calc, as you can see here. I'm going to press shift cos. We see the cos -1. I'm going to type in this. I'm going to use the divided by sign, 8 divided by 12, just to show you that it's the same as a fraction. Doesn't really matter. You must have the brackets in there though, because that can make a really big difference if you don't. I'm going to press equals, of course, and it comes up with 48.1896851. Now, this is a much more challenging question for the last part of it, of course. You know, I'm seeing those three things starting off with. I'm happy if you get there, by the way. But I've been a little bit mean because I've asked in this question to round to the nearest minute. So I know we've done a lesson on looking at some calculations with things to the nearest minute. Now, technically speaking, 5.3, it's what we'll be doing. 5.2, we don't see it as much in year 9, but certainly we do see it in year 10. Remember, the bubble button, which I'm going to show you in a moment, looks like this. That's what turns it into degrees, minutes, and seconds. You can see when my cursor is right there. I'm going to press that, and look what happens. It says this is 48 degrees, 11 minutes, and 22.87 seconds. Remember, it's degrees, then minutes and seconds. And I know that when you type it into a calculator, you don't see that little degree and the dash and the double dash. You just see like a little degree box. But here we certainly see it in our answer. So what it's asking us, if we can see the first bit is our degrees, the second bit, which is the 11, is our minutes, and the last bit is our seconds, we want to round it to the nearest minute. Okay, now I'd only ever do this if I want the nearest minute. If I want the nearest degree, just round to the nearest whole number. But in this instance, the seconds is 22.87 seconds. Now, thinking about seconds and minutes, we know that the magic number is no longer 5, it's 30, right? Because half of a degree or half of an hour is 30 minutes, half of a minute is 30 seconds. Now, 22.87, well, that's less than 30 seconds, isn't it? So what our answer will remain as 48 degrees and 11 minutes. If it was 30 seconds, it would go up to 12 minutes, okay? But again, I don't really mind so much in 5.2 that we're not looking at that last part of that question for minutes. But certainly majority of our questions will be rounding to degrees, okay? But I thought I would throw that one in there just on the off chance that you might see that question. Okay, question 5, as I said, majority of questions will be to the nearest degree. That's what I'm concerned with. Can you do this question? Pause it, see how you go. All right, 15, we're going to label it. It is the opposite side. Of course, the 12 is our adjacent side. Looking at our SOHCAHTOA, again, I always like you to write it out just so you remember it. We can see that this is TOA. So my first thing I must see, tan theta equals 15 over 12. I must see that. I'm recognizing, hey, I'm finding an angle, got to press shift, okay? Tan to -1, and then we've got 15 over 12 as such. I'm going to grab my calc out as we can see. Shift tan, hopefully tan -1 comes up, it does. I'm going to type in 15, I'm going to use a fraction button this time, over 12. Okay, I'm going to close my brackets. I'm going to press equals. We get theta equals 51.3401 ... Now again, this one says the nearest degree, nearest whole number, theta equals 51 degrees, and that's job done. Now, of course, I could press my degree button and it says 51 degrees, 20 minutes. Of course, 20 minutes is less than 30 minutes, so it stays at 51. I wouldn't bother doing that if it's the nearest degree. Only if it's to the nearest minute, I would bother pressing that little degrees button. Gents, that is finding the angle of a right angled triangle using trigonometry. I hope that made a little bit of sense to you. Please practice lots of these questions. Any questions, please ask. Apart from that, I hope you're doing well, and have a great day.